What exactly is going on in my soda right now? Bubbles are coming from somewhere, and I know it will go flat eventually. But why? These sound like pretty simple questions, but the principles this solution follows are important for understanding chemistry. So let's unpack it. This is Real Chem. In my opinion, a good soda needs lots of bubbles, and these come from dissolved CO2, which is a gas. The amount of CO2 that will dissolve in water increases when you increase the pressure of the gas above the water. In a soda can, the pressure is about twice that of the atmosphere around it, and that gas is pretty pure CO2. This leads to a lot of it being dissolved in the soda. When I open the tab, the gas on top of the liquid is quickly released, but the gas that is dissolved in the water comes out much more slowly. This slow process leads to the bubbles we see. Eventually, most of the CO2 is gone and the soda goes flat. The solubility of a gas depends on both the partial pressure of the gas and the temperature of the solution. Now, what if I diluted my soda with another liquid? Would it be less fizzy or more fizzy? Well, I guess part of the answer lies in how well they mixed. If I added orange juice to my soda, it would quickly form a homogeneous solution. In other words, they are miscible because they form a uniform solution with a similar amount of dissolved gas, but now in a larger total volume. But not all liquids are miscible. If I was crazy enough to pour olive oil into my soda, for example, they would simply not mix. I could shake this up like crazy to try to get it as uniform as possible, but it wouldn't mix at a molecular level. I would just get drops of oil in soda or small drops of soda in oil. We can think of oil and water or water-based solutions like my soda as two very different solvents. If I add a substance to my mixture like CO2 for fizziness, I could see whether it goes into the oil or into the water. If it prefers the water, we'd say that it was a hydrophilic substance. If it prefers the oil, we'd call that a hydrophobic substance. This tendency to be one or the other is one of the most important properties we can know about a substance. It tells us where a molecule is likely to go in our body. Hydrophobic substances get trapped in fat, while hydrophilic substances get excreted in urine. Or where substances may go in the environment. Hydrophobic substances end up in the soil, while hydrophilic substances end up in our rivers and lakes. Understanding solutions is crucial for the food industry, for sanitation and healthcare, for environmental protection, pharmaceuticals, and so much more. In this unit, we start by looking at the properties of solutions before unpacking their relationships with gases, solids, and other liquids. So enjoy the journey and don't let your soda go flat. Now let's get to work. This is Real Chem.